This is Neha, and in today's video we are going to discuss some question and answers related to the topics difference of sets, disjoint set and complement of a set. So let's see our first question, which is if set A contains the elements 3, 6, 9, 12, 15, 18 and 21, set B contains the elements 4, 8, 12, 16 and 20, set C contains the elements 2, 4, 6, 8, 10, 12, 14 and 16. Set D contains the elements 5, 10, 15, 20. Now we need to find the difference between the sets A and B, B and C, D and A and D, as well as the difference between the sets C and B. Now pause the video and try to solve it and play the video again to see how you answered. Now let's see the answers. So what will be A minus B? A minus B will contain all those elements which belong only to A but not to B. So 3, 6, 9, 15, 18, 21 are the elements which belong only to A but not to B. Then the next one, B minus C. B minus C will contain those elements which belong only to B but not to C. 4, 8, 12, 16. 4, 8, 12, 16. This belongs to both the sets. But 20 is the only element in set B which is not present in set C. So, B minus C will contain only one element, that is 20. Now let's see D minus A. D minus A will contain all those elements which are present only in D but not present in both the sets. So, what are the elements? 5, 10, 15, 20, and we can see 15 in both the sets. So, D minus A will contain the elements 5, 10 and 20. Now let's check A minus D. A minus D, that means the elements belong to only A but not to D. So, elements belonging to only A but not to D. What were the elements? 3, 6, 9, 12, 18 and 21, as 15 belongs to both A and D. So, we won't consider 15. So, A minus D will contain 3, 6, 9, 12, 18 and 21. Now, let's check C minus B. C minus B means all those elements which belong only to set C but not to B. So here it will be 2, 6, 10 and 14. So these are the elements which belong only to C. Hence C minus B will contain 2, 6, 10 and 14. Hope you have got the right answers. Now let's move to the next question. If U, that means the universal set, contains the elements 1, 2, 3, 4, 5, 6, 7, 8 and 9, and set A contains the elements 1, 2, 3 and 4, set B contains the elements 2, 4, 6, 8 and set C contains the elements 3, 4, 5, 6. So you are provided with the universal sets set A, set B and set C, and you need to find A complement, A union B whole complement, A intersection C whole complement, B minus C whole complement and A complement whole complement. Again, pause the video and try to solve it, and we will see the answers in the next slide. Now, let's see the answers. So let's see what is A complement. A complement. The set A complement will contain all those elements which are present in the universal set but not in the set A. That is, we need to do U minus A. So, as 1, 2, 3, 4 are present in set A, so we won't consider 1, 2, 3, 4 here. Our A complement will contain the elements 5, 6, 7, 8 and 9. Now let's see A union B whole complement. Here, firstly we will perform the operation of union between the sets A and B. So, what will be A union B? A union B will contain all the elements from the set A and set B. That is 1, 2, 3, 4, 6 and 8. And then A complement, all elements which are present in U but not in A union B. That is 5, 7 and 9 are the elements which are present in the universal set but not in the set A union B. So this is a set A union B whole complement. Now let's check A intersection C whole complement. Again, firstly let's find A intersection C. A intersection C will contain the elements 3 and 4, as these are the elements which are common between the sets A and C. Then we'll perform A intersection C whole complement. That means the elements which are present in U but it should not be present in A intersection C. So 1, 2, 5, 6, 7, 8 and 9 are the elements which are present in the universal set but not in the set A intersection C. Now let's see B minus C whole complement. So firstly, again we will find B minus C. B minus C will contain all those elements which are present in only B but not in C. So B minus C will contain the elements 2 and 8. Okay, so B minus C has the elements 2 and 8, and B minus C whole complement will contain the elements which are present in the universal set but is not an element of the set B minus C. Hence, the elements of the set B minus C whole complement are 1, 3, 4, 5, 6, 7 and 9. Now, what's A complement whole complement? A complement whole complement is one of the property of complement of sets, which is law of double complementation, according to which A complement whole complement is equal to the set A itself. Now let's see the next question. Which of the following pair of sets are disjoint? So here you are provided with 3 pairs of sets, A and B, C and D, E and F. You need to find which of the pairs are disjoint. So again, pause the video and try to find the disjoint sets, and we will see the answers in the next slide. Now, let's see the answers. So, the first pair of sets are set A contains the elements 1, 2, 3 and 4, and set B is X such that X is a natural number and X is greater than equal to 4 but less than equal to 6. That means the set B contains the elements 4, 5, 6. As you can see, the element 4 is common between the sets A and B. So, the set A and B is not a disjoint set. Now let's check set C and set D. Set C contains the elements A, E, I, O, U. That's the set of vowels. And set D contains the elements C, D, E and F. Here again we can see the element E is common between the two sets. So this is again not an example of disjoint set. Now let's check the last one. Set E and set F. Set E is a set containing the even integers and set F contains the odd integers. So if we find E intersection F, we will get a null set. So we can say yes, this is an example of disjoint set. Hope you have got the right answer. Now let's move to the next question. Taking the set of natural numbers as the universal set, write down the complements of the following sets. Okay, so taking the natural number set as the universal set, we need to write down the complements of the following set. That means we need to find A complement, B complement, C complement, D complement and E complement. So again, pause the video and try to solve it, and we will see the answers in the next slide. Let's see the answers. Okay, so set A is x such that x is an even natural number. X is an even natural number and the universal set is the natural numbers. So A complement will contain odd natural numbers. Again, set B is x such that x is a perfect cube. Means all those numbers which are not a perfect cube will be in the set B complement. So B complement is a set of all x such that x belongs to natural number and x is not a perfect cube. Then set C, the set of all x such that x is a natural number divisible by 3 and 5. So C complement will contain all those elements which are not divisible by 3 and 5. That is, C complement is the set of all x such that x belongs to natural number and x is not divisible by 3 and 5. Now let's check set D. X such that twice x plus 5 is equal to 9. Now if we solve for x, in this case we get the value of x as 2. So all the natural numbers excluding 2 will be the set elements in the D complement set. So D complement is the set of all x such that x belongs to natural number and x is not equal to 2. Now let's see set E. X such that x is greater than equal to 7. So the natural numbers which are greater than equal to 7 belongs to set E. Then E complement will contain all the numbers which are less than 7 excluding 7. Hence the set of all x such that x belongs to n and x is less than 7. Hope you have got the right answer. So, I hope we are clear with all the operations of sets which we have discussed in the lessons of this course. In the next lesson, we will discuss some important formula on sets. Thank you.